Okay. Do question number 37. What is question number 30? What's the answer for question number 37? Question number 37. No one is answering. Is there any issue? Can you test me? If you are not able to open your mic, or please write me. Okay. Are you facing any issue? Because I'm not able to listen your voice. Okay, do this question, please. Do this question. How would you distinguish between baking powder and washing soda by heating?
So when baking powder is heated, carbon dioxide is released.
Okay. When baking powder is heated, carbon dioxide is released. Okay. And this will give you Na2CO3 Na2CO3 dot plus height plus water plus carbon dioxide. Okay. Plus water plus carbon dioxide. Okay. But when you heat washing soda, Na2CO3 dot 10 is 2, or this one. So when you heat it, this does not disintegrate. So we can simply say that because it does not disintegrate, so it means, what does it means? Tell me. It simply means that there is no elimination of carbon dioxide. So we can distinguish that when baking soda is heated, it gives you carbon dioxide, while other does not gives you carbon dioxide. Okay, got it? So today we're going to discuss a very important part of this metals and non-metal chapter, that is metallurgy. So let us start and begin with the metallurgy topic. Okay. So let's start with the metallurgy, means the extractions of metals from the ore. Okay. Got it?
Yes, sir.
Okay. Okay. So if I'm saying here that what is metallurgy? Okay. If I ask you that what is metallurgy? So metallurgy is a branch of science that deal with the extractions of metals. Okay. Means from the starting, not from the, if I'm saying talking about that, from the starting, that if you are extracting the metals, if you are extracting some zinc, okay, so what you need to do first, all the step means all the steps that are included or that you takes when you are extracting the metal from the earth crust, okay, till the metals comes in its purest forms, all that step that you take is called metallurgy. So the branch of science that deals with the study of extraction of metal is called metallurgy. Okay, you understood? Got it? That what is metallurgy? Okay, now metals exist in the two states. Metals exist in two states. Okay, one is the, in our class, metal exists in two states. One is the native state, another one is the, tell me, one is the native state, another one is the combined state. The native state, or we can call it free state. What we called it? Free state. Okay. So here in this form, the metal is not present in the combined form. Combined means it is not combined with some other element. Like, for example, like in zinc, it does not found in purest form. It found in zinc carbonate form. Okay, a zinc sulfide form. You got it? You understood? But in combined state, the metals are present in the stable form of their compounds. Okay. Okay.
Yes.
Okay. So in the native state, we can say that it is a free state. Metal exists in the elementary form, like gold, platinum, silver, copper. Okay, these are the, I mean, sometimes they are also found, but silver and copper may also be found in the combined state. For example, silver can also be found in the form of AgS, and copper can also be found in the form of Cu2s, copper pyrite. Okay, so it can be present like this, but it can be present sometimes in the purest form, like copper and silver, and be found in the purest form, means without combining with the another element. Okay, and here if I'm talking about this combined state, So metal exists in the earth crust in the form of stable compounds. Like for example, if I talk to you about the aluminium exists in Al2O3 dot 2H2O. Okay, like we have iron exists in Fe2O3 or FeO or Fes or Fe3O4. So it can exist in different forms. Calcium exists in calcium carbonate form, CO3, zinc oxide and zinc sulfide and zinc carbonate form. So they are different types of form that an element exists in the combined state or with a stable in the form of a stable compounds. Okay, you understood?
Yes,
Everybody
sir.
understood? So metals may exist in the native state, either in free state, or it may exist in the elemental form. Okay, so please note it down in your copy. Note it down.
Noted, sir. Sir, what
Noted
is
everybody.
the second example that you have given for native state? Gold and?
Gold, platinum, PT, platinum. Done?
Yes, sir.
Yes, sir.
Okay. Let's move further. Who is Shaima? Shaima? Who is Shaima?
Yes, sir.
What's your name?
Shaima.
Shaima. Shaima, you are the new student here, na? Are you in 10th standard?
Yes, sir.
And this is your first class.
No, sir.
Okay. So is that I'm teaching you means I think that you are in, I'm teaching you for the first time because I'm not. Is that true? Is your first class with me?
No, sir. You've been teaching me in backup classes.
Okay. Okay. Now talking to this one, next one is this one. Like a minerals. Okay. Now talking about this one. Now you know this one that minerals or the elements may exist in the purest form or maybe exist in the combined form with the other elements. Okay. Now what we need to do is the next step is that we need to decide from which element, from which type of substance we can extract the metals economically. For example, let we have a soil, okay, soil in a sample of soil, and another one we have Al2O3 dot 2H2O. Okay, this is soil. In soil, we find rarely that there is aluminium metal is present. Okay, or like we have an ore, like we have Fe2O3, the iron. In soil, iron particles are also present, but it is not as much in amount or the ratio of the pure metal or the substance that we are extracting from the soil is not so high as comparison to if I start extracting the iron from this one. So if I talk about that, there is a difference that what is a mineral and what is an ore. So what is mineral? Mineral is anything that is present in the earth crust from which you can extract the metal or which contain metals or elements or substance. Okay, like important substance, we call it minerals. Okay, for example, soil is also a mineral because it consists of elements or substance or compounds. Okay, so anything that occurs naturally in earth crust that consists of some elements, minerals is called, some elements or compounds is called minerals. But from those minerals, from which we can extract the metals economically. Okay, means what I'm saying here, I'm just repeating my statement. let's suppose there is an example, A and B are the two substances. If I extract iron from A, it is costly for me. And if I extract iron from B, then it is easier and convenient for me and it is cheaper. So I will consider B as an ore. B will be considered as an ore and A will be considered as a mineral. Mineral. Okay. And this is also mineral. This is also mineral, but it is also an ore. But it is only mineral, but not an ore. But not an ore. Now you understood the difference between ore. Ore is that mineral from which metal can be extracted economically. For example, let me give you another example. Like I am having example of Al2O3 dot 2H2O dot 2SiO2. This is an example formula of China clay. China clay. And another we have an example of Al2O3 dot 2H2O. This is a formula for bauxite. Bauxite. So if I extract the aluminum from this one, it is cheaper, convenient, or easy. But if I extract the metal from this one, it is expensive, and taking much time. Okay. So which will be considered as an ore, China clay or bauxite? Tell me, which will be? Bauxite will be considered as an ore because we are taking it is okay. And which is minerals? Is this one China clay is mineral or bauxite is mineral?
China.
Both are minerals. Both are minerals. This one is also mineral. This one is also mineral because both of them contain aluminium. Okay, but China clay is only mineral but not an ore, and this is a mineral also an ore. Got it? Bauxite is a mineral but also an ore. So let me explain you right now that those elements or compound, those elements or compound that exist naturally in earth crust, that exist naturally in earth crust are called minerals. We call it minerals. And what are ores? Those minerals from which metals can be extracted out easily, economically, are called ores. Example, Cl2O3, this is an bauxite, is an ore of aluminium. This is China clay. It is an ore, but it is not an ore of aluminium. But both are minerals. So note it down. Note it down. Don't take the screenshot. Every student is requested to make the note properly. Okay.
Sir, the comparison between an ore and mineral is only when the same metal is extracted, right?
No, we have different ores of different metals. For example, the calcium carbonate is an ore for calcium. Ferrous oxide is an ore for iron. Zinc sulfide is an ore for zinc. Lead sulfide is an ore for lead. So we have different. Okay, so if I'm talking about that, this is an ore for aluminium. Al2O3 is an ore for aluminium. Okay, because we can extract aluminium from this mineral. Okay.
Yes, sir.
Copy this one. When you're done, please let me know.
Noted, sir.
Other Shoaib, noted. Tejasvi,
Yes, sir, done.
done. Okay. Let's move further. Now moving to the next part here is that what are the process that we require that we need to do for extraction of metals. Okay, so first of all, first step is that we're going to study the selection of ore, that we cannot start extracting the metal from the soil. Okay, we cannot start the extracting the metal from anything that we found. Okay, for example, if I went to some hill station and I just know this is a special brown color soil, so start extracting aluminium from this one or start extracting the iron from this one. Okay, so this is not. We need to select the ore, the composition of that ore or the mineral, that from which element we can extract it and which will be economical for us. Okay, first of all, what we need to do is there are some step that what we can do here for extracting the mineral. The first step is the selection of ore, suitable ore. Okay, that is ore. The next step is crushing. Crushing means we just find the big humps of that stone like structures, okay, of minerals, okay, or ore. Then we crush it into the powder form. So crushing of ore and powdering it into the and transferring it into the powder form. Okay, got it?
Yes, sir.
Okay, now moving to the next one is the removal. Next one is that this when you crush these stones, you cannot say that 100% it is going to have only the ore particles. It must have some impurities like some silicate, some soil, or some. So we need to remove that one. So that is removal of gangue particle. Gangue means, what is gangue? Gangue means impurities. The, the particles that are impure, or we can say that are like soil, silicate, or something. Okay, so after crushing that, we need to and this step is called enrichment of ore or the concentration of ore. What we call it, removal of gangue means enrichment of ore or the concentration of ore. And the next one is, after you enrich the ore, means if you remove the ore, then we bring the ore in the suitable form. For example, if it is carbonate ore, then we bring it into oxide ore. If it is sulfide ore, then we bring it into oxide ore. Or why we are doing this, we're going to discuss this one when we'll discuss this topic. So what is important here is that after we make the fresh ore, that we remove the impurities from it, we remove each and every impurities from this one, then what we do, we start converting the ore into the suitable form. And this can be done by two steps, mainly roasting and calcination, then reduction. After this one is reduction means if removal of oxygen. For example, if you have ZNO, okay, ZNO, then you have to remove the oxygen. So removal of oxygen is called reduction. And then purification. So these are the steps that we'll study each and every one by one. So let us start studying. The first one is the enrichment of ore. Okay, so how can we do the enrichment of ore? That's going to explain you here that there's different types of ore. There are four types of ores. There are four types of ore. One is the halide ore, or we let carbonate ore, carbonate ore. The second one is sulfide ore. The third one is oxide ore, and the fourth one is halide ore. Let me discuss that what is halide, what is this one. Let me discuss each and everything. So carbonate ore means that it should have CO3 group in there, like we have calcium carbonate, CaCO3, like we have zinc carbonate, okay, etc. Sulfide ore is ZNS, like we have ZNS, zinc sulfide. Okay, means it should have sulfide, like we have zinc sulfide, lead sulfide, etc. Okay, oxide ore means it should have only oxygen, like we have Al2O3, like we have other Al2O3 can be an example. Okay, Fe2, Fe, Fe3O4, etc. And halide ore means, what is halide? Halide means halogen. Halide means halogen, and halogen is the group 17 element. And what is group 17 element? You don't know. Halogen. So what is halogen? Let me explain you that what in chemistry is called halogen. Group 17 element, the periodic table that you have seen in somewhere in your book. So periodic table consists of this element: fluorine, chlorine, bromine, iodine. This is group 17 element, and this is called halogen. This is called halogen. So this is 17th group element. 17th group is called halogen. So if an ore has any of this element with this one, then it is considered to be as halide ore. For example, NaCl, sodium chloride. So this is an halide ore because it consists of halogen, that is chlorine. These are all halogen. Fluorine, chlorine, bromine, iodine are called halogen. Like we have Na, like we have KCl. Okay, so like we have PbI2, etc. So this is the, we can say that these are the halide ores. Okay, you understood now?
Yes, sir.
Understood. Now for different types of ores, we have different types of separating system. Okay, so just we are not just studying this each and everything in detail, just going to discuss only the means just giving you some knowledge that the first step is the for the enrichment of ore is the gravity separation or hydraulic washing. And what is gravity separation? What is hydraulic washing? The same thing, that we have this type of structures. Okay, and this has pit inside it, and we just put the ore and the gang. Okay, ore along with the impure ore that is consisting of some soil particles or sand, and we just pass the water over it. Okay, the water stream. So this actually work on the principle of a specific gravity difference. And what is specific gravity difference here? Means the density of ore and the in the impurities inside it. Okay, the silicon, the silicate that is present. So if the ore particles are heavier, if they have high density, and then the if I comparison it with the gang, that is impurities that like soil particles. So if the heavier ore particles are heavier, and the soil particles or the gang inside the ore that is mixed with it is lighter, then what is going to happen? Then if we, when we pass the stream over it, then the soil particles start flowing with the stream, and this ore particles settled in the pits. Okay. Okay, so this is the enriched ore. This is the enriched ore. Okay, so it work on the principle of a specific gravity difference. So this is the hydraulic washing work on principle of a specific. It is being written on the principle of a specific gravity difference. Okay, so note it down. A specific gravity means density. Done? Shaima, are you getting?
Yes, sir.
Okay. And you, Abir? Tejasvi, Shweb?
Yes, sir.
Yes.
Shweb, are you there?
Yes, sir.
Are you getting? Beta, honestly, I want to say something to you that you are a very good student. You are performing well. I have seen that in your test copies. I have checked your test copies. Okay, there are silly mistakes, some silly mistake that you are making. Otherwise, you are having good skills of learning, and you have the good skills of writing the answers also. So I want to say something that you need to study a little bit harder. And if you are having any issue regarding to any topic, then you can tell me. Okay, we'll have extra classes. We'll provide you the video lecture to this, because I want every student of mine should top in their classes. Okay, so this is very much means this is the only fee for me that you are just paying. Actually, your students, your parents are paying us, but the students can pay me this one. Okay, I would like to appreciate, or I thanks you if you start working hard, and if you score very good marks in your examinations. So it will be a gift for me that if you are going to achieve very good marks. So that's why I'm just teaching you. I'm just every time if you are having any doubt regarding to anything, just tell the Learnivio team, then they will arrange the extra classes for you. Okay. And if you are having any doubts, let me know. Okay, we'll clear this. But for this, you need to study, because for starting the doubt, to know that I'm having doubt in this one, for that you need to study. Otherwise, if you don't study, you don't have any doubt. Okay. Are you understood? Should I move
Yes,
to the next one? So
yes, sir.
specific gravity means for this means I have talked to you that there are 4 types of ores. One is the carbonate ores, Okay, like we have discussed carbonate ore, sulfide ore. Okay, and we have discussed the oxide ore, halide ore. So the mainly the ore that can be enriched by this method is the carbonate and oxide ore. Okay, so carbonate and oxides ore are enriched by this method. Okay. Okay, have you noted this one? Carbonate oxides ore are enriched by this method.
Yes, sir.
Yes, sir.
So now you understood that what is specific gravity difference? This work on the difference on the principle of specific gravity difference, gravity separation. And what does it have and how does it work? That the heavier particles settled in the pit and heavier particles of ore settled in the pits, and the impurities that are having lighter particles that flow with the stream of the water. Okay, got it?
Yes, sir.
Got. The next one is, I'm just writing this one. Next one is Froth flotation method. This is a Froth flotation method. I'm not just going to explain this one because it is not in the syllabus, but I'm just going to give you some idea of this one. Okay. Okay. We're just giving you the idea that what is Froth flotation method and for which type of ore it is responsible. Okay. So I'm just going to explain it. So this is a Froth flotation method in which what we do, we have this type of ore, and this is suitable for the enrichment of sulfide ore only. Sulfide means which is going to have sulfide particles. Okay, so this work on the principle of priority of wettability, or we can say the principle of wettability. Okay, so if I'm saying that this is the air high pressure air comes from this one. Okay, high pressure air, high pressure air. And what happened here is that we just prepare a solution of sulfide ore, just sulfide ore, okay, and some amount of detergent. Detergent is also added. Some amount of detergent is also added. Okay, got it? Now what happened here is when we prepare the solution of this one, okay, like we have added sulfur and 1% pine oil, 1% pine oil. So just listen to me. What happened? If you just imagine a solution having some water, water is also present. Okay, water is also present. So water mixed with pine oil, mixed with sulfide ore and little amount of detergent. Okay, so sulfide ore is going to have some impurities also, like mud or some soil particles. So what happened here is that this pine oil has a priority of wettability. Priority of wettability, what does it mean? The things that can wet some things. Okay, for example, if I told you that there is a mud or soil particles and there is a plastic bottle. Okay, plastic bottle. You both dip this one into the water, which will get more wet. If you are having a cup that is made up of earthen, or we can say that it is a like we have soil. The cup made up of soil. We call it earthen pot, or like. Okay, so if you dip a plastic bottle and an earthen pot into the water, and you extract it out, which will get more wet, a plastic one or a soil one, which is made up of soil? Tell me.
The earthen one.
Yeah, earthen one. You know that because soil particles get more stick, or we can say that water get more priority if it need to choose. So it will get more give more priority to the particles of soils rather than the plastic bottles. Okay. Similar thing is with this one. The particles of water attract the particles of the mud or the soil that is present inside it, and the pine oil give the priority to the particles of sulfide ore. So when you mix the whole solution and you pass the means high pressure air to it, so what happened here? The a froth is formed. Froth means we can say the bubble-like structure that like soap we have. Okay, the froth is formed, and this froth is of pine oil. So pine oil froths make the particle, or we can say the froth of pine oil have the zinc sulfide or sulfide ore particles attached with it, and the water or the is mixed with the sand particles. Okay, so this is how we remove the froth. And when we remove the froth, it brings its along with it this the ore particles, pure ore particle, and the mud that is present in the sulfide ore or this ore gets settled with the or get mixed with this water that is present inside it. So this is how a froth flotation method works. So what is being asked in the examination? It may be asked in the examination that froth flotation method is used for the enrichment of which type of ore? So which type of ore is enriched by this froth flotation method? That is,
Sulfide.
tell me.
Sulfide ore.
Yes, that is sulfide ore. Okay, sulfide ore. So note it down. This important point only. Froth flotation method is used for the enrichment of sulfide ore.
Noted, sir.
Next one is everybody did noted?
Yes, sir.
Okay. You also, Shaima?
Yes, sir.
Noted. Okay. Now moving to the next one is Shweb, noted. The next one is
Yes,
the
sir.
magnetic separation. So it is used for the enrichment of ore, in which either the ore or the gangue particles, either the ore or the gangue, one of them have magnet attracting particles. So what happened in the magnetic separation? Let me explain you. Okay. What happens in the magnetic separations? So if we have this is a belt. Okay. And this is a conveyor belt, and this is the rollers. Here, this roller is magnetic roller, and this is non-magnetic roller. And this is a like conveyor belt which is moving. So when it falls, if it is having the green color non-magnetic substance and the yellow colored substance, that is magnet attracting property. So when the conveyor belt moves, so because magnet attracted, okay, this roller is magnet attracted, so it will be attracted with this one, okay, and will moves to this one. And while the non-magnetic will not be attracted with this roller, it will be separated out. Okay, you understood? Understood?
Sir, where does the ore particles go?
Is I'm audible? Is my voice is coming to you?
Yes, sir. Now.
So I'm saying here that one is magnetic attracted. Let me explain you one more time here that this is the conveyor belt. Okay, this is the magnetic separation, and this is the roller. This is the roller magnet with magnet. Okay, this is made up of magnet. So when the conveyor belt pass over it, when the one substance is having magnet attracting property. So due to this one, if it is not attracted with magnet, it will fall here. Okay, because it will not go like this. And if it is not attracted with this one, if it is attracted with this one, then it will fall here. Okay, so this will be magnet attracted one, and this will be magnet which is not attracted. Okay, this is separate. This is how it is separated. Okay, understood?
Yes.
Everybody understood?
Yes, sir.
Okay. So please note it down. Just make this one. Okay, make this one, please. Done. So magnetic separation can be used for enrichment of which type of ore? In which either the gangue or the ore, one of them has magnet attracting property. Okay, got it? So
Yes, sir.
have you done this one?
Yes, sir.
Tejasvi? Okay. Everybody in the class done? Shoaib?
Yes, sir.
Yes, sir.
Okay. Let's move. So note it down a little bit about this one. Just write this one, only this one. The first two lines. Don't write this one. Working. Okay. This method is used for the enrichment of such type of ore in which either the gangue or the ore has magnet attracting property.
Noted, sir.
Everyone noted?
Yes, sir.
Okay. So let's move further. Let's move further. Okay. Let's move further. So now what we are learning here is that till yet that how to enrichment the ore, how to enrich the ore. Okay, enrich the ore. What we are just learning how to enrich the ore. Enrich means the removal of gangue. Okay, removal of gangue. Okay, removal of gangue, or it is also called the concentration of ore. Concentration of ores. Just coming a minute. Okay. Done. So this is a removal of that how to enrich the ores. Now what happened? We have done. Now we have removed the impurities from the ore. First, what we did? First, we select the ore. We select the means we select the ore from the minerals from which we can extract the metal economically. Then what we does after selecting the ore, like from China clay or bauxite, which we have to take to extract the aluminum. So we selected that China clay is very costly for us. So we throw it out. We don't consider this one as an ore. We just take the bauxite. What happens to the bauxite is Al2O3. It is an oxide ore. So what we does, we remove the impurities from it. We enrich the ore. We crush it and make it into the powder form, and then we remove the impurities. Okay, got it? You understood, everyone? Okay.
Yes, sir.
Then after removing the impurities, we have the four types of ore. One is the carbonate ore, and another one is the sulfide ore. Okay, and the third one is the carbonate ore, oxide ore, and the fourth one is halide ore. You might be okay. Now this one. Now we need to convert this oxide. Next is I have told you that next step is to bring the ore in suitable form. Bringing the ore in suitable form. And what does this word means? Bringing the ore in suitable form. So this means that you have to convert the carbonate and oxide ore into their carbonate and sulfide ore into their oxide form. Means if we are having this calcium carbonate, we have to convert it into calcium oxide. If we have zinc carbonate, we have to convert it in zinc oxide. If we have zinc sulfide, we have to convert it in zinc oxide. Okay, if we have lead oxide, lead sulfide, when we have to convert it into lead oxide. Why we are converting the carbonate and sulfide ore into the oxide form? There's a question. Because it is easier to extract out metal from their oxide form rather than their carbonate or sulfide form. So first, what we are going to do, oxide form is already in oxide form, and halide ore we don't talk about it till yet. Okay, we will talk it later. Okay, now oxide form is also in oxide form. Carbonate ore should be converted into what? Tell me. Carbonated ore should be converted into oxide,
form.
and this sulfide ore should also be converted into oxide form.
Oxide
And why we are doing this? Why we are
because
doing
it
this?
is easier to extract the metal from its oxide form by reduction.
Yes, it is easier to extract out metal from their oxide form than their respective carbonate or sulfide forms. Okay, got it? Got it, everybody? Got
Yes,
it?
sir.
So there are the two type of steps. Yes. Tejasvi?
Nothing, sir. I was listening.
Okay. Let's move further. Moving further is that in this process, carbonates are heated in the absence of air to give the metals. Okay, what we are talking about this one is that in this process, carbonate ores are heated in the absence of air to give metal oxide. Okay, what is calcination? Now we have two types of steps. One is the calcination, another one is roasting. Roasting is done for sulfide ore, and calcination, for calcination, it is done for carbonate ore. And what it does in the carbonate ore? What is the formula of carbonate group? CO3, na? CO3. So do you think that if we have calcium carbonate, if I need to convert it into calcium oxide plus CO3, it is already balanced, na? Sorry, CO2. Here is CO2. It is balanced, na? So do we need an external oxygen for this one? In the case of carbonate ore? Because it is already balanced. One calcium atom, 3 oxygen, 1 and 2, 3, and 1 carbon. So in carbonate form, if we need to convert carbonate into their oxide form, we don't require any external oxygen because internal oxygen of the carbonate is sufficient to produce carbon dioxide, okay, and give the metal to oxide form. So here, what we does in the calcination, the carbonates ores are heated in the absence of air or absence of oxygen. You understood? Understood?
Yes, sir.
Yes.
So what happens in the carbonate in the calcination? That carbonates ore are heated in the absence of oxygen to bring it into the oxide form. Okay, and what happened to the in the roasting? The sulfides ore are heated. Like for example, I'm having ZNS, and I need to convert it into ZNO plus SO2. Can you convert this ZNS into ZNO without supplying the external oxygen? No. Why?
No,
Because there is no oxygen present here, so we need to give external oxygen from outside so that it can bring the metals into zinc oxide and sulfide form. So what we are doing here, that in calcination we heat the metals, carbonate ore in the absence of air and to bring it into the oxide form. And in the roasting, what we does is we heat the sulfide ore. Okay, we heat the sulfide ore in the absence of in the presence of oxygen to bring it into the oxide form. You understood? Understood?
Yes, sir.
So, and what is the other achievement? First of all, that it help. What is the achievement of calcination? Why we are doing calcination? First of all, it helps us to bring the carbonate ore into the oxide form, and oxide forms can be easily extracted. Means metal can be easily extracted from their oxide form rather than their carbonate form. Moreover, if we have some moisture, that for example, if there is some moisture present and we heat it strongly at 900 degrees Celsius, then that moisture get also eliminated. Okay, so moisture is also eliminated out. And the third one is, the important thing is that if it still has some impurities, okay, and that is volatile impurities. What do you mean by volatile impurities? Volatile. What do you mean by the word volatile? Volatile impurities means that the impurities that you can we can say that the impurities that has low melting points. Okay, that don't have very high melting point. For example, if it is have like if it is as zinc, so zinc melt at 400 degrees Celsius. Okay, so if it is having some impurities that is not at means we can say that volatile impurities, so that these can be easily separated out, because when we heat it in the absence of air, we make it like this. Okay, we make a slope like structure, okay, like this, and we start hitting this ore like this. Here the fire is blowing and the ore is here, and the impurities can be easily melt and can be separated. Okay, got it? Understood?
Yes, sir.
So note about the calcination, that in this process carbonate ores are heated in the absence of air to give metal oxide, that is like this. Advantage, oxide forms is easily reducible, and then its carbonate form, and volatile impurities is also removed by this method. And right for the roasting also. This is very, very important part of this chapter. So many times this question is being asked in examination, like what is calcination, what is roasting, in which type of ore we do the calcination, why we do the roasting, which type of ore are suitable for doing roasting. So this keep in mind.
Noted, sir.
Noted. Roasting also, in the presence of roasting, it means we can say that in this process sulfide ores are heated strongly in the presence of oxygen. We need oxygen in this one. Okay, we cannot heat it in the absence of oxygen to give metal oxide, and advantages are same. Both have the same advantages. Oxide form, both have the same advantages. Okay, so you need not to write it here twice. Okay.
Noted, sir.
Everyone, Tejasvi, noted?
Yes, sir.
Shweb, Shaima,
Yes, sir.
Abir.
Done, sir.
Okay. Let's move further. The next one is let's have some question that we have studied earlier. Let's have some question on that topic. Question number 11. Question number 11. Which of the following metal exists in their native state in nature?
Sir, option C.
Hmm?
Option
D.
C.
C. Okay, second and fourth. Yes, gold and silver. Okay. Sometimes copper also, but there is no copper is not written here, so let it be. So electrolytic refining we have not till yet. Okay. Metal is just shining. Topic that we have studied actually, we've studied a little bit part of this one. Calcination roasting. Sodium hydroxide and bubble mixture is observation that elements is. Most of the question is being asked on electrolytic refining. Okay. Question number 39. Question number 39. Why should the metal sulfide and carbonates to be converted into metal oxide in the process of extraction of metal from them? Tell me. Question number 39.
Because it is easier to extract the metal from its oxides than sulfides and carbonate form.
Okay. Very good. Constituents of alloys. Question number 49.
It gets converted into zinc oxide plus carbon dioxide.
Okay, it will give you zinc oxide plus carbon dioxide. Okay. And this one, a mixture of CO2 and CO2S is heated.
We get copper and
Sulfur dioxide.
yes.
Okay. Given below the steps for the extractions of copper from its ore, write the chemical reaction that is involved. Write the chemical reaction that is involved in roasting of copper sulfide. Okay. And roasting of copper sulfide, reduction of copper oxide to copper sulfide, electrolytic refining, and draw the latent enable diagrams. Okay. So this next part, the reduction topic that we'll be going to discuss in the next class. Okay. So that's all for today. We will discuss this one in the next class. That is important. That is going to be very important because in that one we're going to discuss different types of reactions. The reduction with aluminothermy, we called it reduction with carbon, that is smelting. Okay, simple roasting, electrolytic reduction, that we're going to discuss in this next class. Okay, so that's all for today. We'll meet in the next class, everybody. Okay, please try to join on time because if it is requested that every student should notice that we have back-to-back classes. Okay, if we are having, so if you start joining 10 minutes or 15 minutes later, then we will finish the class on time. So it will be you're completely lost. Okay, so that's why I'm saying that every student is requested to join the class.